Hello. Now let's do an example where we solve an SSA triangle. SSA stands for side, side, angle. And of course, if we reverse that and we think about in the reverse order, ASS, that spells a bad word because this triangle's a pane in the SSA. All right, so we have to remember there could be a situation where there are two solutions. Now, in the video before this, we detailed those 5 cases and how we could figure out what type of solutions were possible, what kind of triangles we could be creating, right? But the main takeaway is that if you have an SSA triangle, you must consider, especially if the angle provided is acute, you must consider the fact that you could have 2 solutions. Now, one thing we already learned, if you're dealing with an SSA triangle, that means you can use your law of sines. And briefly, the way we think about law of sines would be A over the sine of A equals B over the sine of B. So let's look at what we have. Let's sketch what's given here and try to determine what type of situation we may have. So I'm just going to draw a random triangle. I'm going to label my given angle B. B is 29 degrees. The side opposite is given, that guy over here, that is little b, is 15. And I could label either of these two sides to be C. If this base was C, then the top angle would be C, and the other side would be A and capital A. And actually, we're not specified here, but we're going to call it ABC. Regardless, I'm going to, in order to align with the way I described them in the previous video, I'm going to call that side C. So we've drawn this, we've listed this out. That would mean this angle must be capital C. I'll have a little a down here, which I do not know, and capital A up at the top, which I do not know. Now, what type of triangle are we dealing with? We have angle 29, side 20, side. Angle, side, side. ASS, bad word, or SSA. All right, so if it's SSA, and especially if this given angle is acute, you must consider 2 solutions. All right, so let's look at trying to set up law of sines to see what we can find. So here I have a ratio B and B. So I'm going to say that B over the sine of B, and the only other variable I'm dealing with is C. So I'll say C over the sine of C. Or plugging in those numbers, that's 15 over the sine of 29 equals 20 over the sine of C. Okay, so now we cross multiply. When I cross multiply, that gives me 15 times the sine of C equals 20 times the sine of 29, or the sine of C is 20 times the sine of 29 divided by 15. Now, we are solving for C, which means I need to get this sign away. Remember, sine is an operation, so I need to use the inverse operation to get it to the other side. This is going to be that C equals sine inverse, or arcsine, of 20 times the sine of 29, all divided by 15. Now, this may be kind of complex for you to plug in your calculator. One thing I want to remind you, since we're dealing with angles measured in degrees, your calculator needs to be in degree mode. And I would encourage you to pause real quick, make sure you can type this in using your parentheses properly. So sine, we have to use parentheses to open up that sine inverse, and then 20 times the sine of 29, all divided by 15, close your sine inverse parentheses. And what we determine is we get that C is approximately 40.2716871. That's the decimal I exactly get on my calculator. Of course, these decimals keep going. So we get this C value, which is acute. Now, we need to remember what we learned about inverse functions and inverse sine. Where is inverse sine defined? So inverse sine is defined between negative 90 and 90, or negative pi over 2 and pi over 2, only on this right half of our unit circle. So it's always going to give me an angle measure in quadrant 1. Of course, we know we can have an angle measure in a triangle, which is greater than 90 degrees. I could have some obtuse angle rotating off of 0 over here. The calculator is not going to give me that number, okay? We could have an angle somewhere between 0 and 180 degrees, even though the calculator is always going to give us an angle between 0 and, well, technically negative 90 and 90, but we're going to get a positive number. So what we do after this first step where we find that first angle, we're going to set up two cases. I'm going to say case 1 and case 2. So case 1, we have our givens. We have that B is 15, C is 20, capital B is 29, and then capital C we just found is 40.27. Or we have case 2. B is 15, little c is 20, capital B is 29. Those were all my givens. What could be my other option? So we say, all right, well, this guy to here was 40.27. So by symmetry, we know that this must measure 40 by 27. I'm sorry, 40.27. And if I take that away from 180, I also have this option where C equals 139.73 degrees. And that's found by taking the 40.27 away from 180. So when you're dealing with a side-side angle triangle, you are always going to determine this angle first. That's always the way it's going to work. And your next step is to just create two cases. You're going to have your acute angle, and then you need to look at what happens where C is obtuse. What would that same acute angle be if it were over here in my second quadrant? And again, the reason we always get an acute angle here is because inverse sine has a range restriction. All right, so make sure you understand that, but now we're going to move along and we're going to use law of sines to help us solve for this third missing side and the third missing angle. Well, very easy. I'm going to work over here on case 1 first. Very easy. I can determine what angle A is because I know the sum of these two angles. What we know are that all three of the angles are going to add up and equal 180. So 180 minus B, which is 29, minus C, which is 40.27, gives me angle A, which is 110.73. Now, I want you to be very careful and try to use exact values or store values in your calculator, because if you're going to need to use this for a calculation. And when you round it, I've rounded it to 2 decimal places. I've significantly lost some data. So using this rounded value in a calculation, I might get my decimal place a little bit off on A. I encourage you to keep as many decimal places as you can, at least for your calculation. Or again, use the store feature on your calculator to store that value and use it. All right, so our last step here is we'll find side A. And the way we'll do that is we'll use the law of sines. I'm going to say B over the sine of B, 15 over the sine of 29 equals little a over the sine of this approximate value we just found, 110.73. With a quick cross multiply, we get this, divide by sine of 29. I have 15 times the sine of 110.73. Use your answer button or store that value, and then divide by sine of 29. And in my calculator, I get 28.93721187. That means I'll come over here and I'll say that A is approximately 28.9. All right, so those are my 3 values that I would be finding for case 1. Now we'll look at case 2. Case 2, I'm again going to subtract these 2 angles from 180. That will give me A. So I'll say 180 minus 29 minus 139.73. That gives me A, which is 11.27168,721. All right, but we'll just write 11.27 degrees. Again, then we will use our law of sines. Setting this up, I'll say 15 over the sine of 29 equals A over the sine of 11.27. And when we cross multiply, then divide by sine of 29, that allows us to isolate A, typing it in our calculator using an exact function, using either the second answer button or storing that value you found for A to create this precise value. This is the decimal place that I get. And so we'll round that and we'll say, well, that A is approximately 6.05. So there's my second solution for this side-side angle, pane in the SSA triangle. And yeah, so I guess that's it. I just go, go, go. It's really not that difficult. You just want to remember, after the first step, if you're dealing with a pane in the SSA, you're always going to create that second case. If you have any questions, feel free to email me, but there's a potential for 2 solutions. If I give you an SSA on the test, it's probably going to have 2 solutions, and you should know to look for that second solution. As always, have fun out there. Be safe. Good luck. Send me emails with questions. Like and subscribe. All that cool stuff. Have a good day. Bye, guys.